Hello everyone, welcome to this video. In this video we shall be continuing with exercise 9.3 and we'll be solving question number 7 first. So in question number 7 to 10 it is given that we need to find the sum of the number of terms which are indicated in each part. Here we are given geometric progressions in each of the cases. So in the seventh question we can see that the geometric progression that is given to us is 0.15, 0.015, 0.0015 and so on. We need to find the sum up to 20 terms here. So here A is given to be 0.15, that is clear. In order to calculate a common ratio, we will divide the second term here by the first term here. So our common ratio comes out to be 0.1. N is given to be 20 in this case. So we wanted to calculate what is S20 in this case. So because the value of R that is less than 1, so we will use this formula in order to calculate the sum. Sn would be calculated by the formula A multiplied with 1 minus R raised to power n divided by 1 minus R. So your Sn would become, now you will substitute n is equal to 20 into this formula. So that your Sn would become S20, A would become 0.15, 1 would be as such, right? You can substitute the value of R as 0.1. You can substitute the value of N as 20. Again, you can substitute the value of R. After substituting all the values, we need to simplify this expression. So first of all, this subtraction comes out to be 0.9. So you see 0.15 and 0.9, they cancels with each other by 3. So we would have 0.3 here and 0.05 here. So now in order to simplify this further, because we cannot solve this one, we can solve this one. However, the written part, the calculation would be much lengthier. Why? Because it would be 0.000000. How many zeros? In total 19 zeros, and thereafter you would have 1, right? So it would be so lengthier to write. So a more convenient way to write it in this form only, where we have 0.1 raised to power 20. So we will not simplify this thing further. So what do we need to simplify then? We need to simplify just this much portion. So here to simplify this, you see, we can do the calculations just like this. So it would be 1 by 6. Hence the sum up to first 20 terms would come out to be this term over here. Now in the 8th question also we need to find the sum of the first n terms here of this given GP, right? This is the question. For this particular question, we can very clearly see that our first term is square root 7. And the value of common ratio is obtained when you divide the second term over here, which is square root 21. Now you can write square root 21 as square root of 3 into 7, which you may write as square root 3 multiplied with square root 7, right? So the second term divided by the first term. So you see this and this cancels. So square root 3 here is the common ratio. Now what you need to do, you need to calculate the value of Sn from it, because we need to find the sum up to first n terms, right? Now here, because you know the value of R is square root 3, which is greater than 1. So we will use this particular formula in order to solve for Sn. So we will solve for, we will use the formula A into R raised to power n minus 1 divided by R minus 1. So we can substitute the value of A, we can substitute the value of R, right? We do not know the value of n, so we will keep it as such. Now we have noticed that we have a square root term present in the denominator. So that means we cannot leave our question as such. We have to first of all rationalize this. That means we need to remove this term from the denominator. How we can do that? We can multiply both the numerator as well as the denominator by the term which is square root 3 plus 1. So we will have the same term but now with a different sign. So we will multiply in the numerator as well as the denominator both the same terms. So that in the numerator you have a minus b, a plus b. It would be equal to a square minus b square. So it would be equal to square root 3 square minus 1 square. Square root 3 square is just 3, 1 square is 1. So the answer is 2 in the denominator here, right, using the identity here. And the numerator here would be left as such, because even if you multiply you do not reach at any conclusion. So this is your answer. This is the sum up to first n terms of this particular GP which is given to us. right? Now next question is question 9. Here we need to calculate the sum up to first n terms of this particular GP. Here a is not given to be equal to -1, so that means it could either be greater than 1, it could be less than -1, it could be anything but not equal to -1. So here notice that in the question small a is being used as some term. So therefore in order to denote our first term, we cannot write small a here, because in that case it would be the same term as this a. So therefore we need to take another symbol in order to represent our first term. So let's take capital A representing our first term. So because our first term is 1, so capital A becomes 1. In order to calculate what is the common ratio, we will divide the second term with the first term. So it would come out to be minus small a. So this is our common ratio, and common ratio is minus a. It is not equal to -1, so r is not equal to 1. Right, so therefore Sn is obviously not equal to Na. We will not use this formula. So that means we could use either of the formula for r less than 1 also, r greater than 1. We can use any formula. Here I am using the formula for r less than 1. For r less than 1, we know the formula is this one. Whenever r is less than 1, it is the first term multiplied with 1 minus r raised to power n divided by 1 minus r. This is the formula. Now the value of this first term is 1, right? Then the value of this r common ratio is minus a. So we can substitute both the values here. Okay, n is not given to us, so we will keep it as such. So you see, in the numerator we cannot simplify this term further, so therefore we will leave it as such. In the denominator it would be 1 plus a. So finally this would be your nth term. Correct? This is our answer. Now moving on to the next question. Here the given GP is x cube, x raised to power 5, x raised to power 7, and so on up to n terms, right? X is also not equal to plus minus 1 in this case. So here you see the first term is this one, x cube. That is very easy to know. What is the common ratio? It is obtained when you divide x raised to power 5 by x raised to power 3, right? Which is x raised to power 2. Now in order to determine the sum up to first n terms, we need to determine what is Sn. Here your common ratio is x square, and it is not given to be equal to plus or minus 1. So that means r cannot be equal to 1 in this case. If this is not equal to 1, so that means we can use either of the formula, r less than 1 and r greater than 1. We can use any of the formula. So here we are using this formula of r less than 1. Whenever r is less than 1, you have the formula of Sn as a 1 minus r raised to power n divided by 1 minus r. This is the formula, right? So here we can substitute the values of the first term and the common ratio, right, as we have just evaluated these values. Now next thing, you can very easily see this power, this is x raised to power a raised to power b, so it could be written as x raised to power ab. So this thing could be written as x raised to power 2n, and we cannot further simplify the term, so we will leave our solution as such. So this is the sum up to first n terms of this given GP. So I hope you understood these questions well. That is it for this video. Thank you for watching.